SoundWaves.
Sound is a mechanical wave which is created by vibrating objects. A longitudinal wave is where the displacement of the medium is parallel to the movement of the wave. The wave will look like a slinky. Sound waves are longitudinal in the air. Click on the example. As you saw in the first example, the molecules don't actually move down the tube. They just go back and forth in the waves. That's what makes it longitudinal, as it stays parallel to the wave movement. Amplitude is measured from the base to the top of a crest. Wavelength is crest to crest. The longer the wavelength, the less the frequency, and vice versa. Sound can travel through most materials because it's the actual movement of the matter that creates the sound. Sound gets absorbed in some insulation materials because it has the ability to absorb the actual movement, causing no sound. Click on the demonstration to see the effects of sound in different environments.
This is sound from a single source. As you can see, the sound waves go around him, and by changing the amplitude, it changes how wide each wave crest is. The frequency determines how many waves are per a certain amount of time.
As you saw in the demonstration, sound was bounced off of the wall instead of absorbed by the wall, causing the sound to go in different directions. If you went through the air pressure, when there's no air, the sound cannot create noise because there's no particles to move. Sound was bounced off of the wall instead of absorbed by the wall, causing the sound to go in different directions.
Pressure waves are basically the repeating patterns of high and low pressure waves moving through the medium, which causes the disturbance of particles causing the actual sound. The compressions and rarefactions in the actual wave occur because the sound waves vibrate longitudinally, which produces different pressure changes and the different tones of sounds. As seen here on the left-hand side, the tuning fork creates compression and rarefactions, which on the right-hand side you can see the wave is moving back and forth, creating high and low pressures.